Dear students, Assalamu alaikum. We were discussing the process for developing or defining the schema for an objectivity C++ application. Previously, we were discussing what is the format, what is the format of the schema definition file, and what is the process that we follow when we want to define the schema. The slide in front of you now, it basically summarizes the overall process that we follow when defining the schema and what steps are performed there. In this slide, you can see that at the top, we are given two files. One is the boot file and other is the DDL file. The boot file is basically the FDB file. This is the file that is created when you create a federated database. So this you can do through a tool or through the assist, which is a tool provided by the Objectivity DB. So boot file basically reflects or represents the FDB, and the DDL file is the file where you have defined the schema. These two files, they are given to the DDL processor. And as we discussed in the previous lecture, that the DDL processor, it will generate three files, and those three files are shown in the diagram. As you can see, these files are class definition file.h and class definition file _ref.h. These are the header files, and other file is the implementation file, and this is class definition file _ddl.cxx. This file contains the implementation code for your schema. You use these three files in your application, and under the DDL processor you can see the application code. This basically rectangle or this box represents your own application program. और यहाँ पे आप देख रहे हैं कि your app.cxx, this is the file that you create for your application, where you use your .h file that have been created by the DDL processor. Then this application file that you create for your application plus the header files plus the implementation file, all these four files are given to the C++ compiler. And if any objectivity libraries are used within your program, within your application, that is also given to the C++ compiler. The C++ compiler compiles all these files and create an exe file, and that is basically your executable application program or executable application. And this application then interacts with the federated database. उसमें क्या होता है कि ज़ाहिर है कि उसके अंदर you have got the schema, और आप देख रहे हैं कि जो DDL processor है, यहाँ से straight away the schema is moved into the FDB. The schema is there, and plus the data that is created or that is, you can say, entered through your application, that is also there in the FDB. So this is the entire process, a very generic view, a very overall view of the process of building an application using Objectivity DB and C++ as the program interface. Now we move to the next part of our lecture, that is basically the defining persistence capable classes. In the previous lecture, or that was covered in the first chapter of your book, which is basically Objectivity/C++ DDL, data definition language, and it is release 10.0. So previous lecture was from the chapter number 1. Now we are starting the chapter number 2. This chapter basically covers that part of the DDL that basically covers the class definitions, how we define the persistence capable classes. As we have already discussed, that syntax for the DDL is quite similar to normal C++ language. However, DDL extends C++ syntax or C++ constructs by number 1. First of all is that your processor automatically generates the .h file. This is the first thing. Second, that your processor automatically defines the reference file. ये हम देख चुके हैं पिछले lecture में. Then the third extension in the DDL is that it provides the syntax or the statements to define the associations. And finally, it also provides the pragma directive that we have seen in the previous lecture, that is used to basically include the references or the parameterized classes within a program. So these are basically the four extensions that have been provided by the DDL in the Objectivity. Otherwise, all the rest of the things are similar to the C++, normal C++ language. that we have been using. For example, this is a simple example that you can see in front of you, where a DDL file is given, and here you can see how the class has been defined, a class vehicle defined, and it has been made PCC. Then a class truck has been defined, which inherits from the vehicle, and because vehicle is PCC, the class truck also becomes the PCC. The C++ programmer are also used to defining the template classes. That feature is also available in Objectivity C++. You can define the template classes or template PCC here as well. As you can see in front of you, here the definition for a template class is given. You are quite familiar with this type of thing. For example, here you can see that template class T is given. This is the routine C++. However, then your base class is being derived from the public OO obj. This is again the routine to make the class PCC. Then there are two references that have been defined, and again here the type in the references is given as generic because this is a template class. After the definition of the template class, you can see the instantiation of this template class. This class or this template class has been initiated twice, one with the type Cartesian point and other with the polar point. The C++ programmer or the C++ experience, you are familiar with all these things. The only thing is that the template definition or template class definition is supported by Objectivity C++, one thing, and secondly, you can make the template classes as the PCC. This is overall about the defining the class. Next thing is now defining the members of the class. Defining members of the class obviously means two things. One is that we define the attributes or the data members of the class, and second is defining the associations that where we want to define the references to the objects of the other class. Rather the references can be to the objects of the same class as well. So component data means that we define two things, attributes and associations. First we see how we define the attributes in the PCC. As far as the syntax is concerned, syntax is same as in C++, so we don't need to discuss that. However, the primitive data types that are supported in Objectivity C++, they are similar to C++ but with a little bit difference. And that difference is evident as you can see from the slide in front of you. This slide basically contains the category of the primitive data type 1, then the type name that you will use in the Objectivity C++, then the type name that is used in the normal C++ that you are familiar with so far. Then also for the compatibility purposes or just to reflect that the objectivity is compliant with the ODMG standard, the type name used in the ODMG standard is also given, and then the final column gives the description of the type. So first of all, you are seeing that first category is integer, and as you are familiar, as you already know, that the normal programming languages of today, including C++, offer different types of number, or you can say integer types. And obviously the objective offering different types of integer is that you opt a type that suits the data that you want to store, because this doesn't make sense that you use a single very large type of integer for every sort of utility or for every sort of situation or application. Because let's say in a particular situation, your data that you want to store maybe ranges from, let's say, 1 to 100 or 1 to 200. In that case, there is no need for using something like 32-bit long or 64-bit long. That would be basically a wastage of space. So this is basically objective of giving different types of integer, and you are familiar with this concept in normal C++, and the same concept has been provided in the Objectivity C++, and that is given in the slide in front of you. Then other is the floating point. Again, the type name used in Objectivity C++ is given first, and obviously as you can see that every type name is preceded by the term OO, showing the object orientation. and then float 32 and float 64. This is the terminology or name used in C++, normal C++, and you are familiar with that. And next column contains the name that is used in the ODMG standard, that is also given there, and then the description. Then next column contains the character, different type of characters supported in Objectivity C++, C++, and in ODMG. Then Boolean, and then enumeration of any type that you can define in C++ that you can define here in the Objectivity C++ as well. And as the final column shows that enumeration are basically implemented as signed integers. So any enumeration, for example, it could be even like days of week or months of the year or colors or anything, that any enumeration type that you define in your application, that type is actually implemented as integer. Now, this was about the primitive data types that you are familiar with in the C++. Next thing that is important regarding the definition of the attributes is the pointers. As we have already discussed, that the normal concept of the pointer is not of much use here. Why? Because pointers in normal C++, they are used to refer to objects that are there in the virtual memory. So they represent the address space for the virtual memory, whereas the PCC objects, the persistent objects, they are stored in the disk. Their address space is much larger as compared to the address space of the virtual memory. So their OID is very different from the OID of the transient objects. So normal pointers that we use in the C++, they are used to refer to the transient object, whereas when we are talking about the Objectivity C++, here the references will be used to refer to the persistent object. So it means the routine or the normal concept of the pointers that we are familiar with in the C++, that is of not much use here. So the pointers concept is changed. One thing, however, in the PCC object, you can also refer to a transient object. So in that case, when you want to refer a transient object, a non-persistent capable class object, when you want to refer that, in that case you can, however, include a pointer, a normal pointer in the PCC definition as well. But you have to be careful while instantiating that particular attribute, because you must be careful, because this attribute would be able to store a reference to a transient object that takes the OID from the virtual memory space. And secondly, when you want to close a transaction, when you want to end a transaction, at that time you should put a 0 in the pointer of transient type object, so that it is known that it is not pointing to any object, because if you don't do that, next time when you fetch that object, even it contains a virtual memory address that can be mistakenly mixed with an OID of the persistent class type. So that may cause ambiguity or error or problem. So it means that the primitive data types, they are almost the same as in the regular C++. However, we need to have different reference type thing, because we are referring to the persistent objects in the Objectivity C++. However, we can also use the regular pointer concept in the definition of PCC. This was about the primitive data types and the pointers. And next thing is that for defining attributes, we have also got a provision of object reference type. Like, it means that we can declare an attribute of type primitive data type that we have already discussed, or it can be a pointer in the special conditions, special cases, or it can be an object reference type. This is a smart pointer, and it references basically objects to other objects. And as I told you, the object to which this attribute is pointing, it could be of the same class type, or it could be of class type of another class. and the type of such attribute is OOREF. This we will be using later. Keep one thing in mind, that the OO handle, it cannot be used to refer to the objects of the other class type, because OO handle can be used to store the handle to a particular class only. But when you want to store, when you want to refer the objects of some other class type, in that case you have to use the OOREF. Now, as you can see in front of you on the slide, that this class basically it contains a class definition. One is the vehicle, and in the vehicle you can see it contains OOREF and to fleet. Fleet is basically the other PCC type, and the fleet starting with the small f is basically the name of the attribute. Likewise, in the second class definition you can see OOREF, again a smart pointer, and vehicle. Now this vehicle is basically the PCC name, persistent capable class name, to which the vehicles, now vehicles 100 is basically an array of 1000 components. So vehicles starting with the small v is basically the name of the attribute, which is of array type with 1000 components, and each component is basically pointing towards an object of type vehicle. So this is how you declare an attribute of OOREF type. Then there is another type that can be associated with an attribute, and that is the embedded class. This is a class which is non-persistence capable one, or you can call it a structure. So an attribute can be of class structure given there are some conditions. One is that it is obviously a non-PC. Secondly, this definition has no virtual base class. Thirdly, it cannot contain association, and it has only some fixed or allowed data types. The example is given here on this slide. As you can see, first we have defined a structure with the name point, and it has got basically two attributes, both of type OOINT32, and next we have defined a PCC named line, and this class defines an attribute points. Basically it is an array with two members, and the name of the attribute is points, and it is of type point. So as you can see here, that you can have an attribute of embedded class type as well, provided certain conditions are fulfilled. Other types that are supported for the attributes are enumerations. You are familiar with that. Basically give names to values so that they are easily understandable. There are certain features associated with them, and you are familiar with that. Then different types of strings. String you are familiar with. To manipulate a collection of characters, you use the term string, and the string types are supported in the Objectivity C++. Then different types of date and time types are also supported. Then there is another type that is supported in Objectivity C++, and this is V-array. We are familiar with array. This is quite similar to that we have been using in C++, but with one major difference, that the size of the V-array can vary during the runtime. This is something different from the routine C++ array. The type name that we use for the V-array is OOVarray, and then we give the type name. Now, the type of the V-array can be any primitive type, an object reference, or valid embedded classes. However, a V-array cannot have another V-array of type of object. So this is a limitation or restriction that is that has been imposed in the Objectivity C++. So that was all about defining the attributes in the Objectivity C++, and the topic so far that was covered in the chapter number 2 of the Objectivity C++ data definition language, release 10. So this was the chapter 2 of the book, covering the definition of the attributes. Now our next topic is defining associations, and this topic has been covered in the chapter 3rd of the same book that we have been using for this part of our course. What is an association? An association is basically a property of a persistence capable class. It enables applications to link persistent instances of one class type to the instances of the other persistent class. So basically you can say that it establishes link between the objects, between two different objects, and those objects could be of same class type or they can be of different class types. So this association or link is established by the association. One way of establishing this link is to use ORF and then class name. What happens then that this establishes a link between two classes. But in this case, what you have done, you are basically declaring an attribute of reference type. Again, in this case, as you can see from your slide, here you are using the ORF, but you are defining an attribute. You are not declaring an association. The difference between using an attribute to hold the reference of another object and using an association is that when you use an attribute to link two objects, in that case, you as a developer or programmer are responsible for maintaining this reference or this link. Whenever there is a change, whenever there is some deletion or a modification, it is your job to maintain that link. But when you implement the link between two objects through association, many of the activities or many of the modifications in the references, they are managed by the system itself. So this is the difference between establishing a link using an attribute or using an association. So when we define the association, then we say that we are establishing a link between the source and the object. Where an association is being defined, that is called the source, and to the one that is being pointed to is called the destination. So in the case of association, we have to specify certain things, and two of the important things are directionality and cardinality. As the name suggests, the directionality means the direction of the association. It means that whether the direction of association is in one direction only or it is in the both directions. That means because the association links two objects, so in the directionality we have to mention that whether the direction is only in one direction or it is in the other direction as well. I can explain you that with an example. Let's say we define a PCC named class, or we can say department. We define a PCC department, and then we define another PCC named employee. Now, as it is very common in the real world that employee belongs to the department. So what we want to do here is that we want to define an association between the PCC department and the PCC employee. If it is in unidirection, if it is in one direction, it means that it is from department to employee, then the link will be established or link will be maintained only in one direction. That is, when you are accessing a department and you want to access the employees of that department, you can simply follow the reference ORF from the department, and then you will be able to access all the employees that belong to that particular department. It means, let's say there are 10 departments, suppose, and there are, let's say, 400 employees. So we can say on average, one department contains, let's say, 40 employees on average. So let's say we have a department named accounts, for example. When you access the persistent object accounts, there will be an association, and that will be basically ORF. Using ORF, there will be an association, and that association will contain the reference to the 40 employees objects that belong to this accounts department. So if it is unidirection, you can access from the department all the employees that belong to that department. But if you want to access from the employee department, from the employee object, the department to which this employee belongs, you cannot access the department. Why? Because the association is being maintained only in one direction. On the other hand, if it is bidirectional means both directions. So in this case, let's say, if we say that there is one department and it on average it has, let's say, 40 employees. So one department object is containing the reference to 40 employee objects that belong to that department, and in the reverse direction, all these 40 employee objects, all of them, they are pointing towards the department object to which they belong. It means now you can access all the employees that belong to a department from one department object, and in the inverse direction, from each employee object you can access the relevant department object. As I told you before, that you can implement the link between two objects through the attribute or through the reference, through the association. The difference between the two is that if you implement the same scenario that I just mentioned, if you implement the same scenario using the attributes, you will be responsible to maintain the references in all these objects. For example, let's say we delete an employee. We delete an employee object. So if you are maintaining the link through attribute, it will be your job to go to the department object and delete the reference to this particular object, this particular employee object that has been deleted. Otherwise, when you will try to access the employee objects of this department from the department object, the department object will try to refer to the all objects including the one that you have deleted, and that may cause the error. So this is your responsibility. When you're deleting the employee object, then you have to manage, you have to adjust the reference to this object in the department object. But on the other hand, if you are implementing this situation using the association, that will be done automatically. It means when you delete an employee object, the reference to this particular object from the department object will be automatically adjusted. What they do, whether they delete that or whatever they do, but it would be managed automatically. It means that next time when you try to access the employees belonging to this particular department, the association will not try to access that object which has been deleted. So this is the difference between, as I told you, implementing a link using the attributes. You can do that, or using the association, one thing. And secondly, I hope now you are clear about the difference between the unidirectional association and the multi or the bidirectional association. Next thing that we need to mention about the association is the cardinality. Cardinality is something that the database students are generally familiar with, but this is sometimes confusing, so we will review it briefly. Cardinality means the number of instances of an object type of an object that can possibly related with one object of the other type. Confusing? Yes. इसको यूं डिफाइन कर सकते हैं कि if we take one single object of one type, and then we see the possibility of the number of instances to which this single object can be associated. This is called cardinality. For example, when we said the department and employee, we take one single instance of the department type. Let's say one particular department, let's say we say accounts. Again, accounts is very popular. Accounts department. We see that this single accounts department to how many employee objects it can be associated. Or we can describe this fact in the terminology of the system. We can say how many employees can work in one department. So one department can be linked with multiple employees. So this is one side, one way of checking cardinality. But to determine or to mention the cardinality appropriately, we need to see it in the other direction as well. So we also have to see that one particular employee, you can think of any particular employee, to how many department objects it can be associated. Obviously, in general, one employee is associated with one department. So we can say in this direction it is many, and in this direction it is one. So then we'll say this is many to one if we see from department to employee, and if we see from employee to department, it is one to many. Dear students, keep one thing in mind, that attributes, associations, their cardinalities, their directionality, all these depend upon the system, upon the particular organization, particular company. As far as these rules, these constraints, these restrictions, these modeling things are concerned, they are never generalized. For example, if you think this exact example that we are discussing, department and employee, we say that one department object can be associated with many employee objects, and one employee object can be associated with one department object. But don't think that this is always true, this always holds. No. Although our general understanding is that one employee belongs to one department or one employee works in one department, but this might not be always true. For example, there can be many organizations where one employee at the same time may belong to multiple departments. So never ever go anywhere to model something or to design something with a fixed mindset. Why? Because in all your experience, in all your previous experience, you have been seeing that one employee belongs to one department, so you say, no, I'll take it for granted, I'll take for implicitly that one employee belongs to one department. No. All these things, they are system dependent, they are organization dependent. So when you go to an organization to model something that you have already worked on, previous experience will help you. Of course it will help you, but never ever make this mistake to model exactly the same way what you have been doing previously. No, you can be badly mistaken and you can make a major mistake there. So never ever take something for granted or by default, but always model the things as per the rules of the system, the particular system that you are working on. So we were discussing different types of cardinalities. So as I told you, there are 4 types, and one to one, one to many, many to one, and many to many. So you will define the cardinality of an association as per the situation that you're modeling. You don't take something by default. Then when you are copying an object or when you are versioning an object, in that case you have to take care of the treatment of the references. What will happen with the association? Because there are different options. One thing is that the reference, for example, when you are copying an object, when you are copying one object to another object, so what should happen with the references? One option is that references should be deleted, one. Secondly, they should be moved. Thirdly, it should be copied. So as you can understand, that deletion is simple. It is straightforward, that the copied object, the object in which you have copied, delete means it does not contain any reference. So neither the original object nor the copied object, both of them, they do not contain the reference because the reference has been deleted. This is one option. Second is moved. Moved means from the original or from the source object, this reference is moved to the destination object. Now the new object contains the reference to the object, to the same object to which the original object was pointing, but the original object, it does not contain that reference. And third option is copy. Copy means that when you copied an object, you copied this object to this. Now this contains the reference to an object, and the same object is contained in this new object as well. So these are three options that are available when you are copying an object or when you are versioning an object. For example, this slide presents you different scenarios. The scenario that has been discussed presents a situation where an association has been defined between a PCC salesperson and a PCC customer or client. Now, an object of the class salesperson is shown as S1, that was pointing towards an object of customer type, and that was C1. So originally there was an association between the S1 and C1, and that was bidirectional. When we say that move, this is a scenario when, let's say, salesperson leaves the company and joins some other company, obviously for better incentives. So what you do, you assign the customers of S1 to a new salesperson, let's say S2. So in that case, what you do, you copy S1 to S2, all the data is copied, and the references are moved. When they are moved, they are no more in S1, but they are there in the S2. What you do, you change the data of the S2. You put the data for the new salesperson to whom you are assigning the clients of S1, and then you delete the S1. You see, as I told you before, that because you have implemented this link through association, as the S1 has been copied to S2, the reference has been moved from S1 to S2. However, on the C1 side, the reverse direction or the reverse reference has been automatically updated. Now the C1 is pointing towards the S2. So this is the difference, as I told you, by if you implement the link through attribute or the association. Now see, here the reference has been updated in the C1 automatically. The second scenario that has been shown in the slide is when the same situation is that you want some other clients associated to this S2, the S2 to whom you have just assigned the customers of S1. In this case, what happens is that you copy. Now what you do, you copy. In that case, you move the reference. In this case, you copy the reference. What you do, you copy C1 to C2. All the data of the C1 is copied to C2, and references are also copied. When they are copied, now C1 is pointing towards S2 and C2 is also pointing towards S2. Then what you do, you change the data or the data members of the C2. Now C2 is another client who is pointing towards S2, and C1 is another client who is also pointing to S2. So this is the scenario where that has been given as an example to differentiate between copying the references or moving the reference. Then there is another aspect of association, and that is the propagating operations. How to propagate a change. The propagation concept you want to use or is useful when you enforce the concept of composition. Composition means that a certain group of objects is considered as a single thing, as a composite thing. In that case, the propagation operations are useful. There are two options for the propagation. One is delete propagation and other is lock propagation. Delete propagation means that when you have defined an association between, let's say, two objects, and you define the propagation as delete. What happens is that when you delete an object, then any object towards this object was pointing, the reference to that object will be deleted, and the object to which this object was pointing, that will also be deleted. This is called delete propagation. So what happens is that, let's say an object A is pointing towards an object B, and you have defined as delete propagation. So when you delete the object A, the reference to B will be automatically deleted, of course, because you are deleting A, but at the same time B will be also deleted, and this goes on. So this is this is an option that you have to consider very seriously before applying it, because if A is pointing towards B, let's say B is pointing towards C, so if you delete A, with the delete propagation option, then A will be deleted, link to B will be deleted, B will be deleted, and at the same time link to C will be deleted, and also the C will be deleted. So this is called the delete propagation. Same is the case with the lock propagation. As you know, there are two types of locks supported in Objective-C C++. One is read and other is update. So when you apply a lock on an object and then you say lock propagation, what happens that the lock that you apply for object A, the same lock will be applied to all the objects that are being referenced by the object A. And again, like delete propagation, this goes on. It means you apply the lock for the object A. Object A is pointing, let's say, towards 10 objects of type B. The same lock will be applied to all 10 objects of B that are being pointed by the object A. Logic, reason. Why? Because this gives a concept of composition, that multiple things are being considered, are being modeled as a single thing. See, whenever some feature is presented, you can always consider a scenario where this option is not useful, is not helpful, is rather damaging. So the point is, if this particular option does not suit an environment, no one is asking to apply you that option. Obviously, you should apply every option where it suits. So when we say that lock propagation means that you apply a lock on one type, it will move to all the objects that are being referenced. It means you should apply the lock propagation only where it is suitable. The idea is that when you want to perform an operation, when you want to access an object A in a particular mode, let's say in read mode or update mode, possibility is it's too much possible. There's a too much probability that you will also perform the same operation on the object referenced by this object as well. For example, in the case of employee and department, when you access a particular department object and you apply for a particular type of lock on that object, it is quite logical to think that basically when you are accessing the department, you will also access the employees of that department. So rather than first applying a lock on the department object and then going for the employee object or any other object pointed to by this employee object, it can waste time. And moreover, it is quite possible that you get a lock on the employee, but when you want to perform some operation on the you get a lock on the department object, but when you want to perform some operation on the employee referenced by this department object, the lock cannot be granted. Why? Because those employees are being locked by some other application. So that could cause a waste of time, that can cause a deadlock and many other problems. So the situation where you want to model a concept of composition, that these objects, although belonging to different class types, but they are accessed and they are processed together. In that case, you apply the lock propagation option. So whatever type of lock you apply on one object, this lock will be applied on all the objects that are being referenced by this object, plus again the objects that are being referenced by them, and so on. So it means that whenever you apply a lock with the lock propagation option, the lock server will first determine all the objects that will have to be locked under this request. One, it determines that, and when it sees that this lock can be granted to all the affected objects, then the lock will be granted. Otherwise, obviously, you will have to wait. And see, this is a very useful concept, especially in the context of object-oriented modeling. Why? Because because it suits the object orientation approach. Why? Because we model things in different classes, but they belong to the same thing. Misal ke taur pe, if you think of a PC being modeled, so we can model like PC in a separate class, then let's say motherboard in another class, then let's say RAM, let's say power supply, then monitor, then keyboard. All these objects belonging to different classes. But when you say a PC, basically a single PC is composed of all these different objects, but that is a single unit. So this is the situation, or these are the situation where this log propagation or delete propagation concept is useful. But rather than thinking of the situations where this concept is not much useful or rather harmful, it is again advisable that use the options only where it is suitable. Don't use it in an environment where it is not suitable. Simple. Then there are two types of storage properties that are associated with the associations. One is non-inline association and other is inline association. See, when you create an object, there is a default association array. Again, whenever you define a PCC, a default association array is associated with this class. So any reference that you define in this class, that reference will be stored in that same array. For example, if you define a class A and you define two different associations, or let's say three different associations in the same class, all those references will be stored in the same default association array. This is the storage option that is called non-inline storage, non-inline, where all the references will be stored in the same association array. Whereas when we say inline association or inline storage, in that case different associations will be stored in different arrays. What does it mean? It means that obviously when we say association is basically implemented through object references. So in the non-inline, all the references are stored in the same array, and in the inline, every association is stored in a specific array. We will continue this discussion in the next lecture. अब मैं आपसे इजाज़त चाहूँगा. अल्लाह हाफ़िज़.